Okay. So for the sake of some clarity, I am doing some change. You take this u as e to the power of minus, because we are this is our initial point is this one, final point is this one. Initial point is p and final point is p dash. So this will become 1 minus 1 minus I into this one minus etc. Okay. So u is acting on psi of r. This is the translation operation, infinitesimal translation operation. You get the new wave function, and that is nothing but psi at r minus delta rho. So this is the initial point p, final point is p dash. So this is its position coordinate is r minus delta rho. So since delta rho is very small, you can take this one as psi of r itself. So we say that wave function at wave function at p and p dash are same. If you do the infinitesimal translation, wave function at both points are same or no, not having much change. Okay. Or you can interpret this idea in different way. Wave function has maximum value at the p and p dash. P also it is maximum, p dash is also at the p dash also it is maximum, like that. So wave function is same at the p and p dash. So now what remains is mathematical expansion. So this psi of r minus delta rho you can expand using Taylor series. So instead of u, you can write this one. Okay. Instead of u, you can write this one. Instead of psi of r minus delta rho, you can write the Taylor series expansion. Okay. So the what is the Taylor series expansion of psi of r minus delta rho? That is psi of r. So using Taylor series expansion. Using Taylor series expansion, psi of r minus delta rho is psi of r, okay, then plus delta rho, then a small change in psi. So dou by dou r of psi of r. Okay. Or I think here you can write it as a minus sign. Let it be minus sign. Plus or minus, a small change. You add or subtract, no change. This is a very small quantity, delta rho, vector delta rho into a very small change in psi plus etc. You can neglect that. So substitute this in the previous equation. So this equation u psi of r, that means 1 minus I into delta rho dot alpha, okay, acting on, so this is acting on psi of r. You should write the right hand side. Right hand side is this one. Here also psi of r you can take in the outside. So you can write 1 minus delta rho. Instead of this dou by dou r, you can write the del operator. It's very careful coordinates. Okay, r theta phi, or you can write the del operator. Since it is only in the one dimension, it is d by dr. If it is three dimension, it becomes del. Okay, so delta rho into del. Okay, now psi of r you can take outside. So instead of dou by dou r, we have written del. So delta rho dot del into psi of r. Okay. Now this can be written as, we know what is linear momentum. We know linear momentum is minus IH cross del, P equal to, in coordinate representation. So we know in coordinate representation, P operator is minus IH cross del. Okay. So instead of del, you can write. So what is del? Instead of del operator, you can write, let this minus IH cross go to the other side. So it is I by H cross into P. So you multiply with an I on both sides. So here I comes, here minus I square, that is 1. So H cross go to the other side. So del is I by H cross into P operator. So instead of this del operator, you can write I by H cross into P. Okay, so the RHS becomes 1 minus delta rho dot del. So del is I by H cross P. Okay, then psi of r. Okay, is that clear? So now compare both the sides. Compare LHS and RHS. So you can see that what is alpha. So this is left side is alpha operator. So one is same, one is same. I is same, I is same. Delta rho same, delta rho same. Psi of r is same, psi of r is same. So what is alpha? Alpha is P by H cross. Okay. So we can comparing both the sides. We can write alpha operator as P by H cross. Okay. So we have found out who was doing this translation. Okay. We assumed that alpha is performing this translation. So now we found that by some simple idea of quantum mechanics, infinitesimal translation, we found that alpha is nothing but P by H cross. So substitute for this alpha in the definition of unitary operator. So unitary operator, therefore our previous equation for unitary operator who is performing the infinitesimal translation. Infinitesimal translation delta rho is now becomes delta rho becomes, so the unitary operator becomes u. Okay, so instead of alpha, u alpha, you can write p, up of delta rho is nothing but 1 minus I by h cross, okay, delta rho dot p, or e to the power of minus I by h cross this one plus etc. we can neglect. So we have found the unitary operator. So we have removed the notation alpha. Instead of alpha, we found p by h cross. So instead of alpha, you are writing p. U alpha becomes up, and here alpha becomes p by h cross. Here alpha becomes p by h cross. Okay. Now you can simply generalize. If you want a finite translation rho, you have to perform many times this infinitesimal translation. So you will get the finite translation. Now we are going to write, so for finite translation, okay, the unitary operator is, so the unitary operator for capable of doing finite translation is u p of rho. So we are changing delta rho into rho is nothing but 1 minus I by h cross rho dot p. Here also you simply change delta rho by rho. So this you can write it as e to the power of minus I by h cross rho dot p. P operator. Okay, rho dot p. Rho is the finite translation in space. Okay. So from this, who is the generator of? So this operator is doing translation. So from this is a unitary operator performing the translation. So who is the generator of translation? From this equation, who is the generator of translation? It is this one, this fellow, P. P is the generator of translation. Okay. So generator of, from this equation, generator of translation in space is P operator, linear momentum. Linear momentum operator actually generates translation. Okay. So we already earlier stated that this generator should be commute with the Hamiltonian. So when the system is translated, Hamiltonian is invariant, so that this generator should commute with the Hamiltonian. Okay. So during our translation, H remains same. So invariance of H implies what? Invariance of H implies under translation. You are doing translation operation. Then H remains invariant means the unitary generator UP. Okay. And hence P, who generates U, should commute with H. Commute with H. H operator. Okay. U should commute with H or P should commute with H. So we can write commutation P comma H equal to 0. So this implies P is conserved. So anything which commutes with the Hamiltonian is a constant of motion. So P is a constant of motion. Or we can say P is conserved. Linear momentum is conserved. So any quantity which is constant should commute with the Hamiltonian. So here P commutes with the H. That means P should be a constant of motion. So this actually leads to the conservation of linear momentum. Okay. So I can write. So what is the reason for this? We started from the homogeneity of space and end up with this result. Okay. So we can say that conservation of P operator or linear momentum, conservation of P of a physical system. Conservation of a conservation of linear momentum of a physical system. What is the reason? Is a consequence of the fundamental reason is why it is due to the translation invariance of Hamiltonian of the system, H of the system. Translational invariance of Hamiltonian of the system, H of system. Okay. Now this is not complete. Conservation of angular linear momentum is not complete. We again have to say that when it is true conservation of linear momentum, if there is no external forces. Okay, that clause we have to add. It is not always constant. Only when there is no external force, conservation linear momentum is conserved. So we have pH equal to 0 means, okay, this becomes 0 only if and only if Hamiltonian is this P is actually minus IH cross del. Okay, P is minus IH cross del. So if H is a function of R, then this P can operate on H. So there should not be a R dependence for H. Okay, so this is true only if H is independent of R. Okay, means even if the position gets changed, Hamiltonian should not change. Okay, so this H is independent of R. What is the meaning of that one? H is independent of R means actually where is the R comes in H Hamiltonian? It is from the Hamiltonian is the sum of potential and kinetic energy. R is not in the kinetic energy. It is only in the potential energy. So the potential energy term V of R is absent in the Hamiltonian. So V of R should be absent. So P of H equal to 0 will be true only if H is independent of R. That means there is no potential term. Okay. Is that clear? So no potential term. V of R. Okay. So no potential means, so this implies no force. No potential means no force. So that supports our conservation of linear momentum. Okay. So there is no external force. P is a constant of motion. Linear momentum is a constant of motion. Okay. I think this idea is clear. So we started from the fundamental reason is space is homogeneous. So in such a space, we did a translation of a system and we end up with the conservation of linear momentum. Okay. Is that so? Finally, you can say that in one sentence, conservation of linear momentum, which is one of the fundamental principle of golden principle of physics, is due to the homogeneity of space. Space is homogeneous. Okay, so we due to the homogeneity of space, we have the fundamental, very important law, conservation of linear momentum. Okay, is that idea clear? Do you have any doubt?